In trigonometry, we often try to solve triangles, finding the missing sides or angles using the given information. There are two important formulas to learn if we don't have a right triangle. If you have a right triangle, you'll typically use the Pythagorean theorem or the formulas we know for the ratios of sides, often using SOHCAHTOA as a memory help to get those ratios. But if you don't have a right angle, you can use the law of sines or the law of cosines. Now the law of sines, it gives us ratios that relate the angle and the side opposite. So just a reminder, little a is a side opposite angle A, which is our angle. Oftentimes we put a theta on the inside of these in trigonometry, but it's also useful to label the vertices of these using capital letters and the sides using small letters. And if we do that, always list the little letters A opposite A, B opposite B, and C opposite C. Now if we have that, we can set up for the law of sines, we can set up a ratio. That sine of the angle A over its opposite side is going to be equal to the sine of angle B over its opposite side. Now it's also true, we might use that ratio, but we also want to point out that it's true for the other angle too, for sine of C over angle C. Now when we have these ratios, we usually only use two of them. This is just to point out that they're all congruent, that if you take sine of the angle and put it over its opposite side, that ratio stays constant throughout the whole triangle. But we'll oftentimes use in these triangles, we'll use, for instance, just pick two of them, like sine A over little a is equal to sine C of angle C over little c. So you might just pick two of them and solve for the missing information in that ratio. Now this is very helpful when we're trying to find the angles. It also can be used to find the sides, but the algebra is a little bit more intense than if we were to do the reciprocals. So just so you know, we usually refer to the law of sines this way with the angles on top, sine of the angles on top, the sides on the bottom. But you can do it if you're trying to find sides, you can put the side on top instead, and that is a valid way of writing the law of sines. And this way, it's usually a little bit easier to find the sides that are missing. So that's the law of sines. Law of cosines, on the other hand, when to find information, the law of cosines is where we make it this information, use this information, and it looks a lot like the Pythagorean theorem. In fact, there's going to be three versions of it that I'm going to show you. They all use the same pattern to them. I'm going to list the third one first because the beginning of it's going to look very familiar. C squared equals A squared plus B squared. That is the Pythagorean theorem. And if we had a right angle, this would be a true formula to use. But if you don't have a right angle, or if you don't know whether you have a right angle, then you have to add on the rest of the formula, which is minus 2ab. So whatever these two values are, a and b here, go here with 2 times the cosine of the angle here. So these two are opposite each other. Notice that if you're given here, if you've got a side and the angle opposite, that's the formula we want to use. So if we know all three sides, we can find the angle given this formula. So the other forms of this, I'll just build my way up. B squared, if we've got B over here, or if we're trying to find B, then what we do is we'd use the other two sides, A squared and C squared, and then notice here this would be 2AC, that's the pattern, times cosine of angle B, which is the one opposite. So these two letters have to be the same letter, just side, angle, opposite it. And then the last form is A squared equals, and we're going to have the other letters, B squared plus C squared. And if we have the BC here, it's going to be minus 2BC times cosine of the angle opposite the side on the other side, so angle A. So these are the three forms of the law of cosines to help us find values. Now, just so you know, these are used in different situations. So we'll learn later which situations to use them in, but just if you know these formulas, these will be able to help you solve triangles when there's not a right angle in the triangle.